Greetings, welcome to Lab 4, Part 4, Confidence Intervals. So in this part of the lab, we're going to take a look at actually creating a confidence interval given some data, okay? In particular, it's based on age of first marriage, of which this graph represents the distribution of the sample. It was a rather large sample. So let's go in and actually take a look at the problem here so we can read it. Okay, so 4.14, age at first marriage. National Survey of Family Growth conducted by the Center for Disease Control gathers information on family life, marriage and divorce, pregnancy and fertility, use of contraception, and men and women's health. One of the variables collected on the survey is age at first marriage. The histogram below shows the distribution of ages at first marriage of 5,534 randomly sampled women between 2006 and 2010. Excuse me, the average age at first marriage among these women is 23.44. In other words, the sample mean is 23.4 and the sample standard deviation is 4.72. So notice that those two numbers are based on, let's go back for a second to the whiteboard here. Those numbers are based upon our sample. In other words, let me come over here. We know that the X bar that we got out of this particular sample right here was given by, let's go look at the number again. That was given by 23.44. That's our X bar from the particular sample. And we know that S here, our sample standard deviation for this particular problem, or this particular distribution here, was given by 4.72, okay? So 4.72. All right, now what they want us to do is they want us to create a 95% confidence interval based upon that. And one more piece of information that we will need is we're going to need to know what the size of our sample is. And so that was 5,534, if I recall correctly. Let's go take a look. Yeah, 5,534. Make sure you get the right numbers copied down. That's huge. All right, so we've talked about how to create a confidence interval in several of our previous lab activities. Let's see if we remember any of that. We know that how to create a confidence interval, you're going to take X bar plus or minus the margin of error, which we were calling capital E in the previous one, where if we write that out in more detail, that's going to be X bar plus or minus the corresponding value of Z star times S divided by the square root of N. Now, you need, of course, to figure out Z star. To know what that value is going to be equal to, you need to know what your confidence level is. So in this particular problem, let's go back and take a look. That was one last thing we needed to write down, I should have said before we started here, is they want us to create a 95% confidence interval. So that tells us that our confidence level is 95%. And since it's 95%, Z star is going to be equal to 1.96. Fortunate for us, in the not too distant future, we're going to allow our confidence intervals to be created by RStudio. We're just going to put in a command and it's going to spit the interval back out for us. But before we do that, we need to have kind of an understanding of how they're created and what's behind them. So doing this calculation of Z star, we're going to be leaving that to RStudio in the very near future. But in the interim, while we're still doing these by hand, it's a good idea that you know that Z star equal to 1.96 came from a confidence level equal to 0.95, okay? All right, cool. So we got that number. And then we also have the other two numbers that we, or excuse me, the other three numbers that we need. Notice that we have X bar, we have S, and we have N. And so we have all of the numbers that we need to be able to create the confidence interval here. Okay, so let's go back for just a moment to our previous slide here. So we see X bar was 23.44. So 23.44 was what our X bar is, plus or minus our Z star. Whoops, we know what our Z star was. That's 1.96 times S divided by the square root of N, where S was 4.72 divided by our square root of N, which was 5,000. 534. Okay. Now, if you want, of course, you could just get out your old trusty calculator and you could do that craziness on your calculator, or we can actually get RStudio to do this for us. In other words, we can open up a chunk in our script and have RStudio actually give that to us. So let's go ahead and do that. Let's go back into RStudio here. Let's go ahead and open a chunk. So let's insert a chunk and let's actually go ahead and type that in. Okay. So let's assign them. I've been debating back and forth whether to do this, but I think I'm going to go ahead and go with it. Let's call it LB for lower bound. And so we're going to come in and put in our X bar, which is 23.44. And then that's going to be times our margin of error, which was 1.96, which is going to be times our standard deviation, which is 4.72. And then that's going to be divided by the SQRT of 5,534. So that value right there is going to be the lower bound of our particular confidence interval. Okay, so let's go ahead and run that chunk. And notice that it didn't give us back the number. It just, well, it does up here in values, but it doesn't do it down here in the output. Okay, so we'll talk some more about that in just a second. All right, let's go do the right bound. Oh, my bad. Excuse me. I made a mistake there. Uno momento, por favor. I'm glad I went and looked up the values and went, wait a minute, it's not 2 years of age. That's supposed to be a subtraction right there. Ah, yes, old age is a wonderful thing, let me tell you. Okay, so take X bar minus the margin of error. Okay, so that we'll do UB for upper bound, and that's going to be equal to 23.44 plus 1.96 here. I'm going to cheat a little bit. We can make our life a little bit easier here. Just come up here, copy that, paste it down here, and instead of having a subtraction there, put a plus in. Okay, and you should be good to go. Go ahead and let's go ahead and run that chunk. And we got an upper bound. Yeah, there. Now if we look up in our values, looks like the numbers are really good. Okay, cool. All right. So now I want to make this look like an interval. In other words, I'd like to make it look like an ordered pair. So what I'm going to do is I'm going to say X is equal to C parentheses LB comma UB. And then last but not least, I will just echo X. And now if I run this chunk, notice that it comes back out and it looks somewhat like a confidence interval down in my output. Okay. All right. Now, one last thing we need to do, we need to interpret this thing. No confidence interval is complete without any sort of interpretation of it. What does it mean? So with 95% confidence, actually, let me help you out here. Just go back up for just a minute. Remember in the true false, as I said, there is a sentence up here that we want. We can actually just steal this sentence from part D from our true false question. And we can come down here and just modify this bad boy to work. We are 95% confidence that the average age of females in America at first marriage is the average age of first marriage of females in the US is between, and then you can put in, drop in your two numbers right here. Okay. So let's see, what are our two numbers? We always should probably round them off to one decimal place. So 23.3 years. 2, we can change this to a 2 instead of an and. Yo, not, yeah, yo, buddy. To what? To 23.7 years. And they asked us to talk about any relevant assumptions that we made here. Well, we're assuming that the CLT works. And what are the assumptions of the CLT? Well, one of the things is that we need independence. Well, we can assume that the samples were independent of each other. They didn't go and find a bunch of women that lived in the same village and all married around the same age or something like that. That they did a good job of the sample and that the sample size was greater than 30. So even though the shape of the original distribution is skewed to the right, that doesn't matter. It's not going to change our results, okay? So I'm going to leave it at that. That ends this lab. So from this point forward, I want you to come down here and you need to put in a header for me here that says text exercises. And then go ahead and copy and paste those from the exercise link and continue on using this R markup file for your homework, okay? All right, if you get any questions whatsoever, please do not be shy about posting questions to discussions, and I'll be happy to help you out.